Welcome to Premath. In this video tutorial, we are going to solve this exponential equation 3 power x plus 4 power x equals to 5 power x. And let me make it clear that we will be solving this given problem by using a calculus. And we will use derivatives, or sometimes we call it differentiation, to solve this problem. Let's go ahead and get started with the solution. And here's the very first step we are going to do. We want to make sure that we should put a 1 on the right hand side of this equation. So I am going to divide this term by 5 power x. If I divide this one by 5 power x, I have to do it across the board. So I am going to divide by 5 power x and then 5 power x here as well. And then this on the right hand side, this 5 power x divided by 5 power x is going to be 1. And here on the left hand side, we will be using this part by using this concept over here. I can write this one as 3 divided by 5 power x, and plus likewise this term could be written as 4 over 5 power x. Now let's move this 1 on the left hand side. So this thing is going to become 3 divided by 5 power x plus 4 divided by 5 power x. When we move 1 on the other side, it's going to become -1 equal to 0. Now let me go ahead and call this left hand side of this equation, this part, I am going to call I'm going to call it function of f of x equals to 3 over 5 power x plus 4 over 5 power x minus 1. And now we are going to take the derivative of this function with respect to x. So this could be written as f prime of x equals to, over here we have some constant fraction power x. So therefore we will be using this rule, f of x equals to a power x, where a is a constant. Then the derivative of this function is going to be this a power x times the natural log of this constant a. So our right hand side could be written as 3 divided by 5 power x times the natural log of 3/5, and then plus likewise 4/5 power x times the natural log of 4/5, and then we know the derivative of a constant is always 0, so I'm going to put -0. So this equation could be further simplified as f prime of x equal to 3/5 power x times the natural log of 3/5 and then plus 4/5 power x natural log of 4/5. And now we can split this problem into two cases. One is going to be on the left hand side, and this part is going to be on this right hand side. Now let's focus on this fraction 3/5, and we know that this is a positive fraction, so that means, but it is less than 1, so I can write 0 and then 3/5 less than 1. That means 3/5 is between 0 and 1. And likewise on the right hand side, this fraction 4/5 could also be written as between 0, 4/5 and less than 1. And now if we use a calculator, the natural log of 3/5 is approximately equal to negative 0.511, which is a negative number. Okay, just keep in your mind. So therefore, this natural log of 3/5 is less than 0, negative number. And likewise, if we take a natural log of 4/5 on the right hand side, this is approximately equal to negative 0.223, and which is again a negative number, as you can see. So that means natural log of 4/5 is less than 0, a negative number. So therefore, we have concluded that this natural log of 3/5 is a negative number, and natural log of 4/5 is a negative number as well. And now let's focus on this 3/5 power x, this part. So I can write now this 3/5 power x, and we know that this quantity is always positive, and likewise this 4/5 power x, this quantity again 4/5 power x is again a positive value. So therefore we conclude that 3/5 power x is a positive value, and likewise 4/5 power x is a positive value as well. So therefore this, when we multiply positive value times negative value, that's going to give us negative value. So therefore 3/5 power x times natural log of 3/5 is going to become less than 0. That means it's a negative value. And likewise, if we look at this next term, we are again seeing a positive times a negative value. Positive times negative is negative, so that means 4/5 power x times natural log of 4/5 is got to be negative value as well. So we know that this whole quantity is a negative quantity, and this one is a negative quantity as well. When we are adding two negative values, so that means f prime of x is going to be negative value as well. So therefore we conclude that f prime of x is going to be negative value as well. So that means this is less than 0. And since we are running out of space, here is our next step. We know that the derivative of f of x is less than 0, a negative value. So therefore, by definition, this function f of x is going to be a decreasing function. So therefore, we conclude that there's only one solution of f of x equal to 0 if it exists. So make sure f of x equal to 0. And now let's notice that in this f of x equal to 0, if I replace this x by 2, then we can see that f of 2 is 0. But you might say, how? So let me go ahead and prove it. And we know that our function f of x equal to 3/5 power x plus 4/5 power x minus 1. Let's go ahead and replace x by 2 to see whether we get 0. Let's go ahead and replace x by 2. So the right hand side is going to become 3/5 power 2 plus 4/5 power 2 minus 1. So far so good. And here we're going to apply the rules of exponent. 3 power 2 is going to become 9 divided by 5 power 2 is going to be 25, plus likewise 4 square is going to be 16 divided by 25 minus 1. Let's take care of these fraction in the bracket. And since we have the same common denominator, we can write 9 plus 16 divided by 25 minus 1. So thus this thing is going to give us 25 divided by 25 minus 1. So that is going to be equal to 1 minus 1. So we conclude that f of 2 does indeed turn out to be 0. So thus we conclude that x equals to 2 is one and only solution for our problem 3 power x plus 4 power x equal to 5 power x. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.